In the energy storage area, we have basically two sizes of projects. We have the grid scale product, which is our SMS product. That gets into the megawatt scale, grid scale, renewable integration. What's different about our technology is we do use 4-quadrant inverters that allow control of both reactive and real power in and out. So in addition to just being able to dispatch the energy into the system, we can act in a voltage regulation mode to deal with the reactive power. So we have large scale systems. We also have smaller scale systems that may be more applicable in some of the industrial things with our community energy storage, which initially has been aimed at some peak shaving UPS type applications in more developed countries, but has a lot of application with some different battery technologies for use in off-grid projects in a number of places. In addition to this, that may be of interest to this group, we're also very active in large-scale UPS projects. We have a UPS product that's used for entire plant backup. So the systems are in the megawatt range. The largest system we have installed is about 8 megawatts. They can be up to 20 megawatts. They can be installed outdoors and are used for protecting critical loads as well as the services of those loads. So in places like semiconductor manufacturing, where you need to have critical process to grow wafers and other items, of course you can't interrupt that power. But if you lose your air conditioning or your environmental protection or your emergency services, that can be just as bad, causing evacuations. So we have a lot of expertise in providing backup for that, and the ability to start chillers under our UPS load and provide a bridge over to diesel generators for large-scale power. And we've been moving more into the data center market with very efficient, small-scale items. And in places where a building space can be at a premium, being able to install outdoors is fine. The India environment, I know people are very concerned. It gets very warm here. We have these systems installed in the deserts of Arizona, deserts of Texas. So the type of temperatures that you're dealing with in India is something that we understand.
The solutions we are building, they have several applications. Our first entry market is for peak shaving applications in places like New York City, where people pay a high premium for power. So there is a very high cost per kilowatt in addition to the energy cost. So our systems can be used for peak shaving applications in those scenarios. Other applications we are pursuing are renewable integration, where there is a need either to buffer short-term fluctuations or to shift some of the energy. And we have collaborations with Consolidated Edison to design systems that can be used for substation support. So the idea in New York City, and this might be a little bit different here in India, is that there are situations in which the distribution becomes overloaded at peak time, and so the idea is then you can use energy storage. So we have two types of chemistry. We have a nickel zinc flow assisted battery with very long cycle life and can be charged and discharged fast, or at the slower rates. But the idea is that you can fully charge or fully discharge this battery in half an hour or longer. And they look a lot like lead acid, but they use a new technology basically that allows us to extend the cycle life of nickel zinc batteries. Traditional nickel zinc battery only lasts typically less than 1,000 cycles, while our batteries, we think they will easily achieve the 10,000 cycles, and we have several batteries under testing and they have surpassed 5,000 cycles. So the other chemistry we have is a lower cost manganese zinc chemistry that was developed with funding from DOE, ARPA-E, and again Consolidated Edison. And this one will still have about twice the cycle life of a lead acid, but it's very cost competitive when compared to a lead acid. Now, the idea of these batteries in both cases is that even at this high charge-discharge rates, you can still extract about 80% of the capacity in the battery.
Sits at the intersection of energy, IT, telecommunication, and technologies. So, one can simply say that it is the integration of available tools, technology and process into transmission and distribution network and smart meter for the customers. What are in India, we are having the three major concepts and which is being implemented, reduced T&D losses, as you may be aware. India T&D losses are more than 40% in majority, some of the state, and it is higher than, unfortunately, than Nigeria even, or Pakistan by 1%. Second thing is peak power demand. Today you are seeing, I think, this electricity, in Gujarat generally it is 24/7, there is no, but some of the state, it is 4 hours, 5 hour power cut already it has started in like Uttar Pradesh or in Andhra Pradesh. And most important is integrate renewable distributed generation to the grid efficiently, which is I think you all are interested. So the purpose of the MAMA is the demand supply gap and high unsustainable losses. As I already mentioned, it is nearly 32%. So what are the pillars? Transmission optimization, demand side management, distribution optimization and asset optimization.
IFS, Infrastructure Leasing and Financial Services. This company was conceptualized in 1987, almost 25 years before, when India was thinking that how do we commercialize the infrastructure projects at the national level is. So Government of India, through its various public sector undertakings and private sector undertakings, came forward and formed this company. If I start from north, currently we are developing I think a 20 kilometer long tunnel in Kashmir, which we are implementing on the concept of smart tunnel. On central of Delhi, you people are aware, Delhi-Noida toll bridge. 12-14 years before we implemented, this was one of the first urban, I would say, intelligent express was built at that point of time. A lot of projects in between, and then especially in the power sector also. You go to south, I'm just naming a few projects which are really known in the country. In early 90s, we started a project which was called Tirupur water supply. That time commercialization of water was a big challenge. And Tirupur is a place where the textile industry was facing problem of water. So we form an SPV with the local stakeholders, companies and implemented. And we are also currently a very leading company, I would say, in power sector. We are implementing around 4,000 megawatt power plant at Kadlur. We are also doing on the renewable sectors in solar, wind and other things. I don't know the statistics will be. So we always see future projects, and that's how we came up with Government of Gujarat and implementing.
Briefly mentioned, this is a Government of India initiative for leveraging the vast knowledge in industry, academia and research for formulation of appropriate policies and programs for accelerated development of smart grids in India. So why smart grids in India? We have much bigger challenges, much bigger problems, so we need smart grids. It's not a luxury, it's more of a need for us, because you've been here last 3-4 days, you would have heard different discussions. So although we are the 4th largest power system in the world, our per capita consumption is 1/4 of the world average. So our power system need to grow at much faster pace for several decades more, doubling every 10 years for next 3-4 decades. So today it's already 200 gigawatt, 215 gigawatt, doubling in 10 years. That pace of development need to keep. So we need much smarter system, and today we have 12% of renewables. In Clean Energy Ministerial Prime Minister said that we are committed to double it in next 5 years. So that pace of more and more percentage of renewables adding into the power system require again smarter systems. Even in larger rollout of smart grid projects also, we see a much better business case here, and we have a much bigger need and a bigger problems to address to. So it's going to be, that's the reason why government has taken this initiative of forming a PPP model. It's much like the Gridwise Alliance in the United States. The Ministry of Heavy Industries, which is pursuing one of the world's largest electric vehicle program, 6 million electric vehicles by 2020 on Indian roads, 4 million two-wheelers and 2 million four-wheelers, which again requires smarter systems. So MHI is also working closely with us. And just yesterday, the railways is one of the largest consumers of electricity. Railway has joined India Smart Grid Forum just 2 days ago.
Is an innocent user of the storage system. You know, we have been doing off-grid solar photovoltaic for quite some time.
Yes.
And if Eminari is known, it is known for its attempt to provide lighting or other small electrical requirements to those people who probably cannot think of getting so far. In providing this off-grid lighting and other systems, the weakest point we found was the storage battery. Yes, we used lead acid batteries. We know its chemistry and its technology, but in the actual field condition, it has betrayed. But for that, if you see the product today, solar lantern or solar home lighting system, these are actually very expensive systems still today, not fully reliable. And why it is so expensive, why it is not reliable. So, but if we can really bring out a good lighting system which is reliable, which is available everywhere at 700, 800 rupees, we believe the flow of money to the people today is to that extent that people can purchase it from the shops, from the rural shops. Now where is that bag?
So and that's the fun about it, because actually I had kept it in the bag and just sharing with so you at the end of the presentation. But you exactly mentioned something which shows the entrepreneurial spirit of India. This is a company named Bottom of Pyramid Energy and Environmental Innovations. I think I mentioned to you about it earlier. This is started by two young entrepreneurs who were working with Ford in US for almost 10 years. They are part of the Ford innovation team working on Ford electric hybrid. But they had an opportunity to, as part of their MBA class, work with Professor C.K. Prahlad and got inspired, did a case study on looking at what can be done, how you can bring the reliability of manufacturing in US and automobile for bringing down solutions to India. And originally they started with the concept of a stationary bike of things, whereas they wanted to develop something right from scratch which can meet the cost point for the consumers. And their first product was, they called it Chakra, which is a sort of a stationary bike with a integrated generator with flywheel and everything, where you can basically charge a lamp within 10 minutes of biking, and it can provide light for up to 6 to 8 hours depending on the lighting level what is chosen. But again, at the same time, they found some challenges where the lots of interest after the solar policy was announced was on solar powered lights. So although practically perhaps the stationary bike is a more cost effective solution, where the way they had priced it, the stationary bicycle along with the generator would cost somewhere around 8,000 rupees. But the idea is only one person in a village or maybe two people in the village can buy bikes, or maybe as part of the corporate social responsibility these bikes can be provided, and other people just buy lamps which will cost exactly 700 rupees. That's also their calculation, and they just basically bring it to the shop owner. Either they buy it themselves or the shop owner keeps someone who is biking it for the people. In 10 minutes they charge the light, go back home and use it in the evening. So that was their model, and they have some of the villages around Pune, as well as I think they have now I think almost more than 200 such systems being used in different parts of India. But this is just their latest product, where they've come up with it, where it has a integrated solar panel, it has a charge indicator on the side, it has a overcharge protection, everything, and the light level has 2 light levels. So depending on what you want to use, you can either use it just as a dim light for providing basic lighting level, or if students are using it for something, or people are using it, then they can opt for the higher lighting level. But obviously it will have a trade-off in terms of how long the light will last. And they are looking at actually additional innovation, where they may add like a small occupancy sensor chip, so that they are realizing that if people leave it on, then battery may discharge fully. Instead of that, if there is no one around or people go to bed, then suddenly the light will turn off. When people get up in the middle of the night to drink water or something, light will turn on. So these type of things are happening, and what's amazing for me to see is, like, when I'm talking about these things, I'm seeing actually people like Ashish and Aniruddha, who are the entrepreneurs doing this. actually working with, going down to villages, finding the system, and at the same time, they are making sure that it is not just the cheapest products which are used and try to sell it. They have done their detailed sort of engineering analysis. They are working with leading companies like A123, SAFT and others in terms of looking at different type of batteries.